Hi, this is Leslie Langnaw, Managing Editor of Design World Magazine, and I'm here with Mike Walczak here at the Renishaw booth, and we're going to show you this brand new linear encoder. And what is it called, Mike?
LinAC.
Okay. And how does this work compared to other types of encoders?
Well, what makes this one novel is the fact that most encoders are optical or magnetic, and the scales are active, or you have some sort of active element. This is different, is the fact that basically it starts out as a steel rod as our sensing element, and you'll see it right here. Get the steel rod, and then we machine it. We put grooves in. The grooves are about 0.5 millimeters.
Okay.
In spacing, and this is a pseudo-random code, so it's an absolute encoder. All right. At which point we plate it up with copper to fill in the grooves, and then we chrome plate it, and you wind up with a rod that looks actually like this one.
Okay.
And this is a hardened rod at that point, and it can be used like in applications like in pneumatic cylinders, hydraulic cylinders, other actuators, maybe possibly LVDT replacement. It all depends. Anyway, sorry.
Are there any limitations to using it? Are there some applications you wouldn't want to use it in?
At this point, extreme environmental conditions when you get down below -10 at this point.
Okay.
So we're good to like -10 to +85, I believe, right now. Okay. And yeah, I think that's the only real limitation that we have.
What's the resolution and the accuracy like?
We can go down to half a micron. 1 micron is probably more realistic. Accuracy is plus or minus 20 microns, and we think we can probably improve on that in the future.
Why did you guys decide to do this style, this design?
In the world of hydraulics or hydraulic cylinders, the holy grail is encoding the rod. And for many, many years, people are using magnetostrictive sensors and optical sensors and things like this. This actually, we can encode the rod that's part of the hydraulic cylinder and wrap, obviously, the sensing element or sensor around that rod.
Okay.
Okay.
So actually, you've reduced the number of components that you have to put into an assembly.
Correct, and we eliminate gun drilling. That was the big one, actually. And all the processing and making the rods, or actually in sensing or making sensors for the rods themselves.
Okay.
Okay.
So is this available now for engineers to use?
Yes, it is.
So tell me how this works.
Right, inside the reed head, we have a custom ASIC that we developed over the past few years. And you can see that it's on this board on the back side. And on the back side of the board, we have a very strong rare earth magnet. And what happens is when this rod is going through here, it actually magnetizes a small area of the rod, which we can see the groove pattern that way.
Okay.
All right, and from the grooves, the space in between, it will generate a sine-cosine pattern internally, and from there we can interpolate the distance between the grooves.
Okay.
And so that way we know where we're at, and then we can, as far as on a coarse scale, because of the new pseudo-random code, and then we can get to a very, very high resolution as far as the bits in between. That's why I get to the 1 micron.
Now, can you give a home for it? You can set it up a home position for it?
You can, but it's not really necessary because it is absolute.
Okay.
All right, so long as you know where you're at and you know where home's supposed to be,
Exactly.
you're in good shape.
All right.